Hello, Ms. Treadway here. Today we are talking about complementary and supplementary angles, and we are going to work some problems with them. So first, let's talk about what complementary and supplementary angles are. Starting with complementary angles, they would be two angles whose sum is 90 degrees. So here we have a couple examples, starting with angle A and angle B. They're complementary because they sum to 90 degrees. 40 plus 50 is 90. Also, angle C and angle E are complementary because they sum to 90 degrees. 60 plus 30 is 90. So complementary angles sum to 90 degrees, and it's just two angles. Supplementary angles sum to 180 degrees. Again, two angles. So angle J and angle K would be supplementary because 50 plus 130 is 180. Angle M and angle R would be supplementary because 70 plus 110 is 180. So complementary angles are two angles who sum to 90. Supplementary angles are two angles who sum to 180. All right, now before we move on to some problems, let's talk about how we write verbal expressions into algebraic expressions. So when a switch takes place or when we're talking about comparing two values using words. So when you're working a word problem, you need to convert it into an algebraic equation that we can then solve. This is an important skill. So starting with this first example, 3 less than 3 times a number. So starting with 3 less, that's going to be minus 3. And I'm going to put that at the back. So minus 3, 3 times a number. That's going to be 3x. Okay? So that's our first example. Our next example is 7 more than twice a number. So 7 more is going to be addition, and I'm going to put that at the back. So 7 more than twice a number. That's going to be 2x. So those are the two examples that we're going to work for converting verbal expressions to algebraic expressions, and now we're going to move on to some practice problems. All right, so we're going to move on to some practice word problems now, and something else to keep in mind, when we see words that say an or the angle, that means we're talking about x, and when we're saying the complement, we mean the expression 90 minus x, and when we're talking about the supplement, that's going to be 180 minus x. So that's something that you should memorize. So starting here with example number 1, I'm told I want to find the measure of an angle if its measure is 60 more than that of its supplement. So I'm finding an angle that is 60 more, so that's going to be plus 60, than that of its supplement. And remember, looking up here, I'm going to write the expression for supplement as 180 minus x. And I now have an algebraic expression that I can solve. So if I'm going to move x to the other side to combine my like terms, I get 2x. And I can combine this 180 plus 60, and that's going to give me 240. So my last step to solve for x is going to be to divide by 2. And I get that x, or the angle measure that we're looking for, is 120. Okay. Let's move on to number 2. I want to find the measure of an angle if its measure is 78 less than that of its complement. So I'm still finding an angle, which is x. 78 less, that's going to be minus 78. And that of its complement. Complement is 90 minus x. So I'm going to put that in. And now again, I have an algebraic expression to solve. So I'm going to move my x's all to the same side. And I'm going to combine my constants. So 90 minus 78 is 12. So if I'm left with 2x is equal to 12, I just divide by 2. And I get that x. The angle measure is 6. Okay. Number 3 is next. I want to find the measure of an angle if its supplement is 10 more than 3 times that of its complement. Now this sounds a little bit trickier than it is, but let's just dissect the wording that we have here. Find the measure of an angle if its supplement, so let's start by writing our expression for supplement. Remember, that's 180 minus x. So 180 minus x is 10 more, plus 10, than 3 times that of its complement. And remember, we're going to write complement as 90 minus x. And so now I have it's a more challenging expression, but it's algebra nonetheless. So first what I need to do is distribute this 3 to everything inside my parentheses. So everything on the left side of my equal stays the same, and on the right side I'm going to get 270 minus 3x plus 10. And on this one I have a little bit more switching I need to do. So I still want all my x's together, and I want to move this 180 to the other side. So I'm going to end up negative x plus 3x gives me 2x. And on my right side, I've got 270 plus 10 gives me 280 minus 180 leaves me with 100. So then I divide by 2 on both sides, and I get that x, the measure of the angle we're looking for, is 50. All right, we just got 2 more to get through. Here on example 4, I want to find the measure of an angle if the measure of its complement is 48 more than twice the measure of the angle. So again, this sounds harder than it is, but let's dissect what words we have and put in our algebraic expressions. So starting with its complement, remember we write complement as 90 minus x. So its complement, 90 minus x, is 48 more, remember that's going to be plus 48, then twice the measure of the angle. And remember we use x for the angle, so that's 2x. Now I want to solve my expression. So let me move all of my x's to one side and move all of my constants to one side. And I'm going to get 90 minus 48 is 42. 2x plus x is 3x. And so now all I have to do is divide. And I get that x, the measure of the angle, is 14. And last but not least, example 5. The measure of the supplement of an angle is 60 less than 3 times the measure of the complement. So the measure of the supplement, 180 minus x, is 60 less, that's going to be minus 60, 3 times the complement. And so similar to number 3, I need to distribute the 3 to what's inside my parentheses. And as always, I need to combine my like terms and solve. So on the left-hand side, I'm going to get 2x. And on the right side, I have 270 minus 60 and minus 180. And that's going to leave me with 30. So then I divide by 2. And I get that x, the measure of our angle, is 15. Now that we have worked a couple algebraic problems involving complementary and supplementary angles, we are going to move on to some theorems about complementary and supplementary angles. So starting with this example at the top, in the diagram below, we're told angle 1 is supplementary to angle 2, and angle 2 is supplementary to angle A. So we want to find out how big, what the measure of angle 1 is and what the measure of angle 2 is. So remember, supplementary means they sum to 180. So that means that angle 1 plus angle 2 equals 180, and angle 2 plus angle A equals 180. All right, and we know that angle A is 70 degrees. We're told that right here. So I can rewrite this as angle 2 plus 70 equals 180. And I can solve for angle 2 by subtracting 70, and I get that angle 2 is equal to 110. So I've solved for angle 2. Now let's find angle 1. Well, angle 1 plus angle 2, which is 110 degrees, is equal to 180. So I can solve for angle 1 by subtracting 110, and I get that angle 1 is equal to 70. So if angle 1 is also 70 degrees, then I can conclude that angle 1 is congruent to angle A, because angles that have the same measure are congruent. And this proves this theorem we're given right here, that if angles are supplementary to the same angle, then they are congruent. Angle 1 and angle A were both supplementary to angle 2, so they are congruent to each other. Okay. Another scenario for that problem is right here. If I'm told angle 3 is supplementary to angle 4 and angle 5 is supplementary to angle 4, I want to prove that angle 3 is congruent to angle 5. So again, supplementary, they add to 180 degrees. So if angle 3 plus angle 4 is equal to 180, and angle 5 plus angle 4 is equal to 180, they both equal the same number, so I could set these two expressions equal to each other. So angle 3 plus angle 4 is equal to angle 5 plus angle 4. Now if I subtract angle 4 from both sides, they cancel, and I'm left with angle 3 is equal to angle 5 in measure. So therefore, angle 5 is congruent to angle 3. If angles are supplementary to the same angle, then they are congruent. Okay. One more theorem we're going to talk about is that if angles are supplementary to congruent angles, then they are congruent. So it works the other way around. So let's look at this scenario we're given here. F is supplementary to G, H is supplementary to J, and then we're told that G and J are congruent. So let's write out some expressions with the information we're given. If F and G are supplementary, that means that they add to 180. And if angle H and angle J are supplementary, then they also add to 180 degrees. And if G and J are congruent, then their measures are equal to each other. So I can set these two expressions, F plus G is equal to H plus J because they both equal 180. And because G and J have the same measure, I can substitute G for J. So I could say angle F plus angle J is equal to angle H plus angle J. And then I can get rid of my J's on both sides. And we're left with angle F's measure is equal to that of angle H. So angle F is congruent to angle H because they are supplementary to congruent angles. So the two theorems we've taken away are that if angles are supplementary to the same angle, then they are congruent. And if angles are supplementary to congruent angles, then those angles are congruent. And these theorems are also applied to complementary angles. So if angles are complementary to the same angle, they are congruent. And if angles are complementary to congruent angles, then they are congruent. And that concludes our notes on complementary and supplementary angles.